Hello friends, welcome back to my channel Ray the Chemist. Today on our show Science Friday, we're going to talk about tectonic plates. So let's get into it. First of all, what is a tectonic plate? So you need to understand that the earth is basically a sphere of molten magma that is surrounded by a crust. So the green layer represents our crust, which is also known as the lithosphere, beneath which lies the mantle. Inside the mantle is the core, and core is considered as the hottest part of the earth, or hottest part inside the earth. So now what happens is that the tectonic plates are formed because of the cracking of the lithosphere. Why does the lithosphere crack? Lithosphere cracks because, as you know, there is very high temperature inside the earth. So when there is a high temperature inside the earth and a low temperature outside the earth, there is a temperature difference which causes the magma to push on the lithosphere. Now these pushes cause these lithospheric cracks. These cracks on the lithosphere, which makes tectonic plates. Now, these tectonic plates are always moving. Reason being because of the movement of the magma inside the earth. Take this for an instance. You have a bucket full of water, and in the water, you have added two table tennis balls. They are pretty lightweight, so they'll float around in the water. Or you can also take some colored crystals, like of potassium permanganate. Now, when you start heating the water from the bottom, that's what is happening on the earth also. Here it is being heated, and the magma is being heated. And let's see what happens. When you heat it, first of all, it sinks down. After which, it comes up. So this circular motion keeps on continuing. That's because, first of all, what happens is when the water is heated, it comes up, and then it comes down because now there is a vacant space down at the bottom, so the cold water will come down, which will also carry these table tennis balls. So we in the end see a circular motion here. Now this circular motion is the reason of the movement of these lithospheric or tectonic plates. Now this movement is continuous, it never stops. Right now also, the lithospheric plate on which you are standing, it may be the Indo-Australian plate, Eurasian plate, African plate, North American plate, South American plate, Atlantic plate, Pacific plate. On whichever plate you are right now, that is moving. Now this movement of plate is studied in plate tectonics. Okay, so now hopefully this idea of plate tectonics, tectonic plates, and the movement of the tectonic plates is very clear to you. Moving on to what happened in the past, or what was the situation in the past. In the past, there was basically a very big continent, also known as the supercontinent, which was Pangaea. It was surrounded by this super ocean also. This Pangaea basically comprised of this Eurasian plate, North American and South American plate, African, Antarctic, Australian and Indian plate. So all these plates were basically part of the connected together and a part of the Pangaea also. Now this is a theory which was named continental drift by Alfred Wegener. Now if you see carefully, you will find that North America and South America, they sometimes look to join together like pieces of a jigsaw puzzle, and also the same case with Africa and South America. So this was a theory that was first given to us by Alfred Wegener, and there are first of all this visual proof that we can see. They look like jigsaw pieces which can be connected together. The other evidence that we found was that same fossils of the, or you can also say same layer soil layer profiles, were found in two different continents. Like the same profile was found in South America and Africa. Both are pretty far away from each other, but still they have the same kind of fossils, same kind of soil arrangement. So that is why we can also say that first of all there was a Pangaea, which was the supercontinent. Now let's talk about some very important tectonic activities to talk about. First one is the most recent one, and that is about the African subcontinent, or the African continent, you can say. This African continent, basically 2 years ago, a crack started to form. This passed through Djibouti, which is a very small country in Africa, to Ethiopia, to Kenya, to Tanzania. This large crack, which is basically because of Africa being formed of two different plates. Now these two plates are moving away from each other. This is causing a very large crack to form in this whole area. This also broke down the highway on this country, on this continent. So very important thing is that it is the eastern side of Africa. It may also break down. And one more very important thing is uh, Madagascar. Madagascar was also earlier a part of the Gondwana, that was 165 million years ago, and its west coast was in Gondwana, which is a part of Africa only, and the east coast was formed 88 million years ago when it broke away from India. Right here you can see Madagascar is right here between the South American, Indian, Antarctic, and also the Australian plate, after which South America and Africa broke away with Madagascar's west coast, and then it broke away from the Indian, Australian, and Antarctican plate to form the new day Madagascar. So, this is a very important thing that we needed to talk about. So, that was it for today's video. Please like, share, subscribe, and do comment. I post regular videos on Monday regarding to rockets. Our theme is Rocket Monday, and on Fridays, just like this one which you saw today, and these are named Science Friday. Please come again to our channel and comment down below what topic would you like to see next. Thank you.